Good day, ladies and gentlemen. I welcome you all to Shitu's Mathematics Coaching Program. Today, we are going to look at another aspect, subtopic under the topics that we started from the last video I dropped, that is complex numbers. So this subtopic we are going to look at is what is equality of complex numbers. Now, before we can talk anything about equality of complex numbers, there is need to know what exactly the complex number is. As you all know that from the last video I dropped, we made mention to us what we really mean imaginary number. That is, imaginary number is any number that is the square root of a negative number is called what is called an imaginary number. Whenever you have a negative number under the square root, that is the radical sign, that is under the square root like this, like -2. This is actually an imaginary number, and this will actually give us 2i. Are you getting what I'm saying now? Or at times, if you have -2, it can also be written as -1 times root 2. -1 times what? -1 times root 2. And you know, I told you that we have I to be root of what? Root of -1. Our I is root of what? Root of -1. Are you getting it? Definitely, if this one is I, we have I multiplied by root 2. We have what? Root 2i, or I root what? I root 2. Are you getting what I'm saying now? So that is what we did. That is the summary of what we did from the last video I dropped. So now today we want to look at what we really mean by equality of what? Equality of complex numbers. So now, before we can do that, as I said earlier, we are going to look at what it really means complex number. So what do you know about complex number? So complex number is a number in the form, let's say we have z. Let's represent our complex number to be z. If you have a number in form a plus I, that is I, which is imaginary, ib. Understand? So this is the form of complex number. If you see a number in form of a plus ib, it is what? It is called a complex number. So now from here, what are the things we need? You can see a, we can see b here. Understand now? So now this a is same thing as what? It's called the real part. It's called the real part because what you can see, actually it is what? It is constant here, but it is the same thing as what? As real part. When I say real part, that is real number part. The one that is not attached to what? To I. So that is what? That is real part plus b is now what? Is now imaginary what? Imaginary part, because it is attached to what? It is attached to I. To our imaginary number. I guess what I'm saying now. So now, if you have this now, so this is called what? This is called a complex number. But at times, we can have our imaginary, we can have our real parts to be 0, so that we have what? We have purely imaginary number. That is when our a is equal to 0, so we have z to be, when a equals to 0, we have z to be what? ib, which is what? Is giving us what? Purely imaginary. Are you getting what I'm saying now? It's giving us what? It's giving us purely imaginary. And at the same time, we can have what? We can have this b also to be what? To be 0. So that the z we have what? We give us, so that the z will give us purely what? Real number. Are you getting what I'm saying now? But completely, if you have this and this, this our, what is it called? The complex number comprises of the real part and imaginary part. So now, mathematically, this is denoted, that is, the real part is denoted as REZ. That is, reals, we normally reals. That is, RE. This RE means what? Real part of what? Of Z. And B is what? This one is what? Is imaginary what? Imaginary part of what? Of Z. I get it? IM. So they are, A is denoted by this, and what? And B is denoted by IM of what? Of Z. That is imaginary of what? Of Z. So that is what? That is just the brief meaning or definition of what? Of a complex number. When you have a complex number in this form, where a and b are constants, and a is called real part, while b is what is called the imaginary part of what? Of this z. So that is what we call what? That is what we call complex number. So now, if you now want to talk about equality of complex number. So before we can talk about this equality of complex number, I urge every one of you to please now do it right now. You subscribe on my YouTube channel, so I'll give you some seconds, like 1, 2, 3, 2 seconds, so that you use that one to subscribe. Then we come back to equality of complex numbers. That is what we want to do today. Thanks. Alright, thank you so much for subscribing. So now we are going to continue with our work now. So equality of complex numbers now. So before we can talk anything about equality of complex numbers, definitely you have what? There must be two complex numbers. So from the definition of complex number, we denote what? A complex number to be z. So since we are having two now, complex number, because I told you before you can say equality of z, definitely one must be equal to the other. So therefore, we have what? We have z1 and what? And z2 now. That is z1 to be the first one and the z2 to be the second one. I get it. So now, if we are having z1 to be complex number, so definitely this can be, for this one, this can be a plus ib, and z2 can be what? Can be c plus id. I get it. So it's not proper and it's not ideal to use what? To use the same constant. Understand? For the both complex numbers. So that's why I try to. So now you can now say these two complex numbers are said to be equal if a is equal to, that is a equals to c, and what? And b equals to what? Equals to d. So if we can say that, so we say what we said, z1 and z2 are equal. I don't know, maybe I get what I'm saying now. So therefore, we compare the what? We compare or we equate the real parts, and we equate what? We equate the imaginary part also. Understand? So that will b equals to d. So if you are comparing, you don't need to what? You don't need to bring out this I again. So we only compare what's the imaginary part. Why the imaginary part here is what? Is b. So that is when we can say z1 is equal to z2. That is equality of what? Equality of complex what? Of complex numbers. So now we now have one example to buttress our point here, to see maybe what we have done or what we have been saying since is what is right or not. So now let's say we have this particular question. Let's say we have this. The question says, if 4x plus I into 3x minus y equals to 3 minus 6i. Solve. So what? You don't need to bring out this I again. So we only compare what's the imaginary part. Why the imaginary part here is what? Is b. So that is when we can say z1 is equal to z2. That is equality of what? Equality of complex what? Of complex numbers. So now we now have one example to buttress our point here, to see maybe what we have done or what we have been saying since is what is right or not. So now let's say we have this particular question. Let's say we have this. The question says, if 4x plus I into 3x minus y equals to 3 minus 6i. solve for x and what and y. Can you see that? So if you look at this equation very well, you can see that the left hand side is what is a complex number, yes, and the right hand side is also what is also a complex number. So now we are having equal sign in between, which means we set this to be what? To be equal to this. Are you getting it now? So now we want to get the value of what? We want to get the value of the variables, that is variables x and what and y. So now how are we going to do that? So now from what from what I said earlier, so you will try to bring out. Okay, let me try to bring these things out. So now let's consider. We'll be considering. Okay, let's consider this. Consider the left hand side, that is LHS. LHS. You see that the RE part here, that is the real part, of this is what? The real part is what is 4. I don't know, maybe I get what I'm saying. The real part, because this is in form of what? This is complex number. We have real part and we have what? We have imaginary part. So now the real part is what is 4. That is our A, if you remember. And what? And imaginary part here. Imaginary part here. That is imaginary part. Imaginary part is what? Imaginary part is what? Is 3x minus what? Minus y. I'm getting it now. So let's consider the right hand side also. The right hand side of this equation, we consider the RE is what is. What is the RE? The RE here is what? Is 3. And we have the imaginary part also. Imaginary part here to be what? Minus what? Minus 6i. Are you getting what I'm saying now? Minus 6i. Minus 6i. No, this one couldn't be what? Sorry, I'm called there was a mistake here. So we have 4x here. So we cannot have, this one is 4x, not 4. Are you getting what I'm saying now? So now, what are we going to do now? We compare. I told you, you equate the both imaginary part from the both sides. That is, from the left hand side we have this, we have this. Therefore, equate what? Equate the both what? The both RE. That is from the two equations. That is, we have what? We have 4x to be equals to 3. I get what I'm saying now. So now from here, we have our x to be, by dividing both sides by 4, we have our x to be 3 over 4. I get it. So you compare, that is, the imaginary, the real parts compare with what? With the real part of the second. And also you compare the imaginary part of the first one to the imaginary part of the second one. So by doing that, the real part and real part from the left hand side and from the right hand side. So 4x equals to 3. Therefore, we dividing through by 4, we have what we call x equals to what? 3 over 4. That's what I'm saying now. So now the next thing is to compare the imaginary part. That is, equate the imaginary part also from the both sides. From the both sides. So how are you going to do that? So now we have 3x minus y equals to minus 6. You should not include this I. The I will not be there. We are only talking about what? About imaginary parts. This is I is imaginary. Understand? This is imaginary, but this is what? Understand? This one is just a part of imaginary. So we have imaginary part is what? Minus 6. So now this gives us what? This gives us another equation. So now, since we are dealing with the same equation, so we don't need to disturb ourselves more. You can see that the value of x has been solved already. So we have x to be 3 over 4 here. The next thing you should do is to employ this x equals to 3 over 4. Indeed, that is, we have what? We have 3 into bracket 3 over 4 minus y equals to what? Minus 6. Are you getting it? So now the next thing to do is to solve this further. By solving this further, Understand? So you try to, you have 3 times 29 over 4 minus y equals to 6. Are you getting what I'm saying now? So now, to make this one in linear, I need to clear the fraction. What do? You multiply all these equations by what? The both sides by 4. So multiplying this equation by 4, what do we have? We have 9 minus 4y equals to 24. Understand? So now, considering this by taking or collecting the right hand, so what do? We have 4y to be equals to what? 33. Are you getting what I'm saying now? So now, from here, what do? You divide both sides by 4. You have 4 divided by 4. So we have y to be equals to 33 over 4. So now, this is where we are going to stop. You can see that we have the values of x to be 3 over 4, and we have the value of y to be 33 over 4. So now, if you now want to know whether we are right or not, understand? So, we said this one and this one, they said to be equal. So let me do this one for you, understand, to see whether we are right or not. So let me draw one box here so that I show the, the result. So now, after we said this one and this one must be equal, before we can say this is equal to this, definitely the real parts must be equal to each other, and the imaginary parts from both sides, complex number must be equal. So now, let's say this one and this one now. We pick 4x equals to 3 here. Understand now? So now, we now go to what we have here. What is the value of x? Just put the value of x inside this. You have 4 into bracket 3 over 4 equals to 3. You can see 4 we cancel 4 here. 3 equals to 3. You can see that we have 3 here to be our real parts. But here, originally, it is 4x. But after getting the value of x, we substitute this was the x for us. And substitute 3 over 4 for x here. So this is what they have here. Therefore, our result gives 3, which means 3 equals to 3. 3 will be here, 3 will be here. So if you do for this one also, all of this one also must be equals to what? Minus 6. So that's the assignment I gave you. So if you now do that and you found that there was a mistake or there is something that you are confused about, so don't hesitate to ask me a question. Understand? And I am here to give you any kind of the possible answer to your question. So that is that for today. So I remain myself, Shitu. But do not forget to subscribe and hit the bell in order to get the notifications of my videos that will be dropping subsequently. So that's where we are going to stop today. So I wish you best of luck. Thank you.